Hey guys, welcome back to our video. So for today's video, we will be tackling about the surface integrals. We will be integrating over the surface of a solid. In other words, the variables will always be on the surface of the solid and will never come from inside of the solid itself. So now, let us go to our first example. Evaluate the surface integral of the double integral z squared ds, where s is the total area of the cone, in which square root of x squared plus y squared is less than or equal to z, that is less than or equal to 2. First, let s sub 1 be the side of the surface of the cone, and s sub 2 be its base. We can then write the given integral as the sum of two integrals that is shown in picture number 1. Next, find the first integral I sub 1 using the formula in picture number 2. From there, we can now find the value of the partial derivatives that is shown in picture number 3. We can then conclude that square root of 1 plus partial derivative z over partial derivative x squared plus partial derivative z over partial derivative y squared is equals to square root of 2. Since z is equals to 2 on the base of the cone, then the domain D of x and y is defined by the inequality z squared plus y squared is less than 4, that you can see in the graph or the picture in picture number 5. Hence, the integral I sub 1 is now written as shown in picture number 6. So, for the polar coordinates, we now have I sub 1 is equals to 8 square root of 2 pi that is shown in picture number 7. Consider now the second integral I sub 2. The base of the cone is described with the equation z is equals to 2. Therefore, we can now find I sub 2 using the formula in picture number 8, where the double integral d s sub 2 represents the area of the base, which is pi multiplied to 2 squared is equals to 4 pi. Hence, giving us the equation in picture number 9 and the value for I sub 2, which is 16 pi. Now, we substitute the value of both the I sub 1 and I sub 2 in the equation I is equals to I sub 1 plus I sub 2, giving us our surface integral for this example, which is 8 pi of square root of 2 plus 2. Now, let's have our second example. Find the integral of the double integral ds over square root of x squared plus y squared plus z squared, where s is the part of the cylindrical surface parameterized by r of uv is equals to a cosine u, a sine u v, where 0 is less than or equal to u, that is less than or equal to 2 pi, and where 0 is less than or equal to v, and that is less than or equal to h. Now first, we calculate the partial derivatives that is shown in picture number 1. Then, find the cross products or their cross products in picture number 2, in which we can conclude that it is a cosine u times I plus a sine u times j plus 0 k. Then, the area element of the given surface that is shown in picture number 3. From there, we can now calculate our surface integral that is shown in both picture number 4 and picture number 5, giving us our surface integral for this example, which is 2 pi a ln of h plus square root of a squared plus h squared over a. That is all for 2 examples. Thank you so much for watching.